Hello there. Here we're going to look at chemical calculations, and basically we're going to explore the concept of mole. So what is a mole? It is a quantity of something, okay? If we say a dozen, in a dozen you have 12 things. So instead of saying 12 things, we say a dozen. So 12 things is a dozen. But a mole is a quantity which contains 600 hexalien atoms. So in a dozen you have 12 things, but in a mole you have 600 hexalien. Look, 600 to hexalien atoms. And this is, we call it a mole. So a mole equals 600 2 hexalien atoms. In the book you have it 600 only. They write 6 times 10 in the power of 23 in the book, but it is actually 602 hexalien atoms, and this is, we call it Avogadro's constant. Avogadro's constant says in 1 mole of a substance there is 600 hexalien atoms. And what is 1 mole of a substance? 1 mole of any substance equals the relative atomic mass of the substance in grams. So carbon, the relative atomic mass of carbon is 12. So in 12 grams of carbon, there how we have 12 grams of carbon, in these 12 grams we have 600 hexalien atoms, 23. So in this dish, if you look here, this small dish, in this dish which contains carbon, in 12 grams you have 600 hexalien atoms of carbon, and the relative atomic mass of magnesium is 24. So in 24 grams of magnesium, here you have 1 mole. 24 grams of magnesium, you have 1 mole of the substance. It means here in this dish, which you can see here, you have 1 mole, which means here only this ribe magnesium, you have 600 hexalien atoms of this element. So here we're going to look at calculating moles. If you have a substance and you want to find the mass and you have the number of moles, so mass in gram equals number of moles times mass of 1 mole of the element. Mass of 1 mole of the element is the ER, the relative atomic mass of the substance. So it is the relative atomic. So carbon is 12. The ER, relative atomic mass of carbon, is 12. So the number of mole times the relative atomic mass of the substance. Here we're going to have a question just to look at this. So the relative atomic mass of iron is 56. Here is the question. Calculate the mass of 2 moles of iron, and how we're going to do this. Here we have the rule says mass in gram equals number of moles times the mass of 1 mole of the element, which is the relative atomic mass. This is the mass of 1 mole of the element. So mass of iron equals number of mole, here we have 2, times the relative atomic mass, here 56. This equals 112 gram because we are looking at mass. So do not forget the gram. If you have a problem like this, if you write the rule, you have 1 mark. If you apply it, you have 1. If you write the unit and the final answer correctly, you have 1 mark. So here this was an element, but if you have a compound like this one, the mass of a compound equals the number of mole times mass of 1 mole of the compound. Here you're going to calculate all the masses of the compound, the elements present in the compound. Here we have example. In the first one we have 1 element only, magnesium or iron, but here we're going to have iron oxide. So this is a compound. So to solve a problem like this, it says mass of a compound equals number of mole times mass of 1 mole of the compound. Here we have the number of mole, but we do not have the mass of 1 mole of the compound. So we're going to calculate it here. So iron, here we have 2 atoms. So 2 times the relative atomic mass of iron is 56. Plus, we have 3 atoms of oxygen. 3 times the relative atomic mass of oxygen is 16. So this all will equal 160. 160. This is the mass of 1 mole of the element. So mass of a compound, mass equals number of mole, here we have 2, times the mass of 1 mole of the compound, 160. This will give us 320. 320 what? Grams, because we are looking of the mass. So if you have a compound, you first need to calculate the number of mole of 1 mole of the substance or the compound. Then you multiply times the relative atomic mass or the over the number of moles. And this is if we have the number of mole and we want to find the mass. But sometimes it gives us the mass and it needs the number of moles. And how is that going to be? Here we're going to look at it. Number of mole time equals mass of the element over mass of 1 mole of the element. This is if you have 1 element, then you're going to divide. How we're going to have an example. Here we have calculated the number of mole of aluminium present in 180 gram of the element. So we have the mass, but we want to find the number of mole, and here we have the mass of 1 mole of the compound, which is the relative atomic mass, the ER. So the rule says number of mole equals mass of the element over mass of 1 mole of the element. So number of mole equals mass of the element, how we have it in the question, 180 gram, over mass of 1 mole of the element, which is 27, and that will equal for what? For moles. This is the unit, mole. If you want to make it shorter, you write mole only without this one. So it equals 4 mole, and that's the unit. But this is what an element. But if you have a compound, number of mole of a compound equals mass of the compound over mass of 1 mole of the compound. So here we're going to find first the mass of 1 mole of the compound, then we have the mass of the compound, which is given in the question. Here we're going to look at an example. Calculate the number of mole of 190 gram of magnesium chloride. So number of mole of compound equals mass of the compound over mass of 1 mole of the compound. First we're going to find the mass of 1 mole of the compound equals 24 plus, here we have only 1 magnesium, and magnesium, the relative atomic mass, 24, plus chlorine, we have 2 times the relative atomic mass of chlorine is 50, 35.5, and this will give us 95 equals 95. So here we have the mass of 1 mole of the compound. So number of mole equals mass of the compound, which is 190, over mass of 1 mole of the compound, which is 95. And this will give us 2, and the unit is mole. So here we first found the mass of 1 mole of the compound, which is magnesium chloride. Then we divided the mass, this over over 190 over the mass of 1 mole of the compound. And that was it about calculating moles. In the next video, we're going to look how to calculate the mass and number of mole of gases. Until then, ciao.